So we'll try to define the derivative by using the limit definition. So let's begin by considering a continuous curve. So this is our curve. Now let's consider a point on this curve. This is point A. So this corresponds to x on the x-axis, and the corresponding y value will be f of x. Now what we do, we consider another point B on the same curve, and let's say this is at x plus h, and its corresponding y value will be f of x plus h. Now recall when we were discussing about the average rate of change, that means the average rate of change between point A and B. So let's join A and B. So that is given by f x plus h minus f of x divided by x plus h minus x. Or this is simply f of x plus h minus f of x divided by h. So this is the average rate of change. Now what we'll try to do, we'll try to bring this particular point B closer to A. So that means if we bring B closer to A, it's the same as saying that this is the h value. So we are trying to make the value of h as small as possible. So let's say if we consider the limit when h approaches 0, then our function f of x minus f of x divided by h, so this becomes the instantaneous rate of change. And in the limiting value when h approaches 0, then a and b is going to coincide, and what we get is a tangent line. So this tangent line is referred to as the derivative of the function x, which is denoted by f prime x. Sometimes it's also referred to as d over dx of the function f of x, means the same thing. So we'll use this limit definition of derivative to solve few problems. Let's try it out. Problem number 1, we need to determine the derivative of the function f of x equals to x squared using the limit definition, and after that we will find the value of f of 2. So let us begin. So our limit definition is limit, so f prime of x, that is what we have to obtain. So this is limit h approaching the value 0, and the function is f of x plus h minus f of x whole divided by h. So let's call this number 1. Now we already have f of x, which is given by x squared. So f of x plus h, so that will be equals to x plus h whole squared. All we have done is we have replaced the value of x with x plus h. So when we expand this is a simple identity, a plus b squared. So this will be x squared plus 2 times x times h plus h squared. Now let's substitute this value into equation number 1. So f prime of x will be equals to limit when h approaches the value 0, f of x plus h, so that's simply x squared plus 2xh plus h squared minus f of x, which is x squared divided by h. So the x squared term gets cancelled out, and then we have in the numerator limit h approaching 0. So let's take h as the common factor from the remaining term in the numerator. So we have 2x plus h divided by h. So here the h and h gets cancelled out. So we have limit 2x plus h. So when we use the limiting value of h tending to 0, so this will be equals to 2x. So therefore, the derivative of the function f of x equals x squared is simply 2x. Now, this is f prime of 2. So f prime of 2 is simply 2 times 2. So this is equals to 4. Let's try out another problem. So in problem number 2, we have the function x cubed. This is a cubic function. We need to determine the derivative of this function as well as determine the derivative at x equals to 3. So let us begin. So we have now using the given value of the function, which is f of x equals to x cubed, we can find out f of x plus h. So we substitute x with x plus h whole cubed, and expanding this will give us x cubed plus 3 times x squared h plus 3x h squared plus h cubed. So f of x plus h minus f of x, so this will be equals to, so we have 3x squared plus 3xh plus h squared multiplied to h. So you can try out the algebra. Now we will substitute this value in equation number 1. So this is going to give us limit h approaches 0. So we have 3x squared plus 3 times x times h plus h squared times h whole divided by h. So h and h gets cancelled. So this is limit x approaching 0, 3x squared plus 3xh plus h squared. So this is simply 3x squared plus 0 plus 0. So our derivative of the cubic function is 3x squared. So this is f prime of x. Now at x equals to 3, f prime of 3 will be simply equals to 3 times 3 squared. So this is 27. Let's do another problem. So we have the function g given by 1 over x. We need to find out the derivative of this particular function. So let us begin. So here, instead of f, we have been provided with g of x. So g prime of x, this will be simply limit h approaching 0. So instead of f of x plus h, we have g of x plus h minus g of x whole divided by h. Now, g of x is given by 1 over x. So g of x plus h, this will be simply equals to 1 over x plus h. Now, g of x plus h minus g of x, so this will be equals to 1 over x plus h minus 1 over x. So we will have x minus h divided by x times x plus h. So this leaves us with negative h over x times x plus h. Now we'll substitute this value. So we have limit h approaching 0. So g of x plus h minus g of x. So this will be negative h divided by x times x plus h. And also we have h in the denominator. So the h from both the numerator and the denominator goes away. And this leaves us with h approaching 0, negative 1 divided by x times x plus h. So let's use the limit value. So we have negative 1 divided by x times x plus 0. And this is simply equals to negative 1 over x squared. So this is the derivative of our function g of x. So here we have the exponential function e raised to the power of x. We need to determine its derivative. So let us begin. So first we use the definition of derivative. So p prime x. So p of x is given by e raised to the power of x. So p of x plus h, that will be equals to e raised to the power of x plus h, or simply e raised to the power of x times e raised to the power of h. Now p of x plus h minus p of x, so this will be equals to, so we have e of x times e raised to the power of h minus e raised to the power of x, or simply if we take e raised to the power of x as the common factor, we have e raised to the power of h minus 1. So that means our definition now becomes, we have limit h approaching 0, we have e raised to the power of x times e raised to the power of h minus 1 divided by h. So here we will take out e raised to the power of x, because the limit is only concerned with the value of h tending to 0. So we have limit h approaching 0, e raised to the power of h minus 1 all divided by h. Now this particular limiting value actually goes to 1. the proof is not shown here. For the time being, we can assume that this value is equals to 1. So that means the limiting value goes to 1, and that leaves us with e raised to the power of x. So the derivative of the exponential function is the function itself. Let's move on to the final problem. So here we have the function square root of x. We need to find out its derivative. So let us begin. So we have f of x given by square root of x. So that means f of x plus h will be equals to square root of x plus h. Now let's find out f of x plus h minus f of x. This will be divided by h. So this is equals to square root of x plus h minus square root of x whole divided by h. Now what we will do, we will multiply the numerator with its conjugate. So that is square root of x plus h plus square root of x. And we do the same multiplication to the denominator as well. Square root of x plus h plus square root of x. So this is going to give us square root of x plus h whole squared. So here we have used the identity that a minus b times a plus b. This is equals to a squared minus b squared minus square root of x whole squared divided by h times square root of x plus h plus square root of x. So this will be x plus h minus x whole divided by h square root of x plus h plus square root of x. So a few of the terms will get cancelled out. So in the numerator, x and minus x cancels out, and also this h and this h goes away, and this is going to leave us with 1 over square root of x plus square root of x plus h. So this is the value of our. Now what we will do, we will take the limit when h approaches the value 0. So this is going to give us 1 over square root of x plus square root of x plus 0, or simply 1 over 2 times square root of x. And this is the value of the derivative f of x.